and observed from the top of a 75-meter high lighthouse from the sea level, the angle of depressions of two ships are 30° and 45°. If one of the ships is exactly behind the other on the same side of the lighthouse, find the distance between the two ships. So, okay, I have drawn the lighthouse, okay, but I haven't drawn the horizontal plane here, so that I can draw the, okay, just 1 second. Okay, fine. It says the angle of depression. So angle of depression, I can mark it here. So the first one, the angle of depression will be, say here, this angle of depression is 30°, and the other one, the entire thing here, will be 45°. Sorry, I made a mistake here. It will be this one as 45° here. So angle of depression is equal to angle of elevation. So I have marked here angle of elevation is 45 and the other one is at 30° here. Now let us start solving here. What do we have to find? We have to find the distance between the two ships. This ship 1 is, say, here at C, ship 2 is at D, or say the ship, there is another, say we have what, the two ships here, C and D. So ship 1 at C and the ship 2 at D here. We have to find the distance between the two. So basically we have to find this length. This length is a question mark. This length is a question mark. What do we do it? We will find out the length DB here, and I will find out the length CB here. From DB, if I subtract CB, I will get DC, which is the required here. Fine. Now how to get DC, right? That we have to calculate CB for that. To calculate CB, yes, we will take the triangle ABC in this case here and find out BC using the 75 meter as height. The angle is 45°. Similarly, taking the bigger triangle ABD, taking 30° and a height is 75, we can find out DB. So once we get these two, we can get the difference and we will be able to find the DC, which is the distance between the two ships here. So let's write here in triangle ABC, so we have got tan 45, so I will write here tan 45° is equal to AB by BC. So AB by BC, and what is AB in this case? AB is 75 and BC we have to calculate. We know that tan 45 is 1, so we can write 1 is equal to 75 upon BC. So therefore finally we will get what? BC is equal to 75 meter. So we'll keep it here. BC is 75 meter here. Now we'll calculate DB. So to calculate DB, we need another triangle which is ABD. So right here we can write in triangle ABD. So right here in triangle ABD, we have got tan 30° is equal to AB upon DB. So what is AB? 75. dB is supposed to be calculated here. We know the value of tan 30. Tan 30 is 1 upon root 3 is equal to 75 upon dB. So dB here will be 75 into root 3. So we got dB also. So dB is okay, we got dB 75 root 3 and BC as this one. So we have to find the length DC. So we know that right here dB is equal to DC plus CB. dB is 75 root 3. DC is supposed to be calculated is equal to 75. So we can further solve. So we can write here. We can write here as DC will be equal to 75 root 3 minus 75. So DC is equal to 75, take it common, root 3 minus 1, and that is equal to 75 into 1.732 minus 1. So we can write furthermore that DC is equal to 75 into 0.73. Now if you multiply 75 into 0.73, let's see what do we get. 54.75. So we get finally DC is equal to 54.75 meter, which is the distance between the two ships, and that is your answer. All right.